AP Chemistry, we're going to finish up the answers videos for the Thanksgiving midterm assignment, going on to problem 20A. So calculate the molarity of 0.492 grams of magnesium nitrate in 250 milliliters of solution. So let's go ahead and do that. So we're starting off here, right? And we're trying to get to molarity. So over here, we're going to put, okay, and we need to figure out the molar mass of magnesium nitrate. So (24.31). You have 2 nitrogen. They are each 14.01 from the periodic table. And then you have 2 times 3 is 6 oxygen. And periodic table says that's 16. So when we add all of that up, we get 148.33 grams. So 1 mole of magnesium nitrate is 148.33. So we're going to go ahead and set up our first conversion here. So grams cancels out. And we have liters of solution. And I should have put that over here. You have that much in 250 milliliters. That's of solution. Okay. And we need to convert that to liters, so we use our standard conversion. Milliliter solution and milliliters of solution cancel. So we have liters of solution on the bottom, moles of magnesium nitrate on the top. Everything is set up. So we're going to do 0.492 times 1 times 1,000 divided by 250 divided by 148.33. And that gives us 0.013. Okay, and that's our answer there. Okay, we're on to our last problem, 21A. So it says, assume you dissolve 3.16 grams of malic acid in 650 grams of water. Calculate molarity, molality, mole fraction. On the next page, it's going to ask us for percent mass, percent composition by mass. Okay, so we're going to need to know both grams and moles on this. So I'm going to go down to the bottom of the page, and I'm going to go ahead and calculate those right off from the very start. So, and I'm simply going to refer to it as malic rather than write that formula out every time. But we do need that formula. We do need that formula to calculate the molar mass. So we have 4 carbons, so 4 times 12.01 plus 6 hydrogen, 6 times 1.01 plus 5 oxygen, 5 times 16, and that gives us 134.1. Okay, so now we can compute the moles of malic acid, and we get 0.024 moles. Okay, now we can come down here and do the same thing for water. Okay, then another property to to remember is this. Let's go ahead. I'm going to go ahead and sneak it in right here. So we have 650 grams of water. Now, hopefully you know how to do this in your head. If you don't, you can do the conversion of 1 gram equals 1,000 1 kilogram equals 1,000 grams. But hopefully you know how to just slide the decimal over 3 places to go from grams to kilograms. So that's how many kilograms of water we have with the decimal right there. And if it's water, for water only, that's going to equal liters. Kilograms to liters. Kilograms equals liters. That's for water only. Of water are what determine the metric system is designed around the properties of water. And one of them is that there's 1 kilogram for every liter of water. That conversion is a 1-to-1 conversion. Okay, so we have this information on the bottom to work with for the rest of this. Okay, so first question is molarity. So we want to find moles. Okay, so moles of malic acid we figured out down here is 0.024. Liters of solution. Well, we have 0.650 liters of water. But that's not the solution. The solution is the malic acid mixed into the water. This is only of the water. So you either one of two things. Either you can't do the problem or you can make an approximation. And the approximation is that if the amount of solute of malic acid is very small compared to the amount of solvent water, then you can say that the liters of water is approximately equal to the liters of solution. So we can come down and say this, that liters of solution, which is what we really need for this formula, is approximately equal, squiggly equal sign, liters of H2O. And this number is less than 1% of this number, so we're going to go ahead and make that approximation. You don't do that, you can't do the problem. Okay, you can just say, no, I can't do it, I don't have the proper information. Or you can say, we can get a pretty close figure if we use liters of water for this. So what we're then simply going to do is take the moles of malic acid and put it over the liters of water. And that's going to give us, and I put 0.24, it should be 0.024. That's our number right there. And that gives us 0.37. And that's your answer, assuming that you accept that simplification. Now, how much is small compared to this? It's your judgment, but it's about 0.5%. So we're going to say it's fine. Okay, molality. Now that one we can do exactly. So we have exactly the same numbers then. Let me give myself some more space here. And of course we get the same. Okay, and I errored up here. It's 0.37. It's 0.037. And this answer is exactly the same. Except for molality, it's exactly correct. For this one, it's a bit of an approximation. Okay, so there's the answers to those two. Okay, mole fraction. So I'm going to try to see if I can find a little space for this. Let me draw a line like that and a line like that. I'm going to squeeze it in here so it's moles. Okay, and we figured out all of that down here. And we get it right there. So that is the mole fraction of malic acid. So it's very, very small amount there. Okay, now we go on to the final part of this problem, and it is asking us for the mass percentage. So now we do almost the same thing as with mole fraction, except with grams. And so we have grams of solution. Really don't need to break them out for this problem. So grams of malic acid was 3.16. And grams of water was 650 times 100%. And we get 0.48%. So about 0.5%. The malic acid makes up about 0.5% of this solution. So it kind of justifies in the first part making the approximation that the volume of water is the same as the volume of the overall solution, because malic acid doesn't make up very much of the volume of the solution. It's very small. Okay, that takes care of all the answers that I'm going to do, all the A questions. You do all the B questions. If you have any issues, I'm going to have tutoring on Friday, Saturday, and Sunday. And come on in and see me, and we will answer any questions you might have then. Okay? All right, good luck and work hard.